Let us find the derivative of inverse cosine of x or arc cosine of x. First of all, since y is equal to inverse cosine of x, it means that your x is equal to cosine of y. You want to find the derivative dy dx. So let us start taking the derivative. Dx is equal to negative sine y dy. Very good. Divide everything by dx. 1 equals to negative sine y times dy over dx. Now divide everything by negative sine y to isolate the derivative. So dy over dx is negative 1 over sine of y. But remember that sine squared of theta plus cosine squared of theta is equal to 1. So sine of theta is plus minus square root of 1 minus cosine squared of theta. We're not really worried about the negative sign here. Why is that? Recall that when we have a function, we say that the function is 1-to-1. If it passes horizontal like this, then we can define the inverse. So recall function y equals to cosine of x. This function oscillates on its domain negative infinity to positive infinity. This is not 1-to-1 on its domain. What's the remedy? You can cut the graph of the function and just isolate the function between, for example, 0 to pi. So between 0 to pi, the function passes horizontal like this. Cosine of x on 0 and pi. Between 0 and pi, your function sine is going to be positive. Sine theta is positive, or it is 0. So sine of y becomes square root of, let's write down 1 divided by square root of 1 minus cosine squared of y. But what is cosine squared? Cosine of y is x, so cosine squared is going to be x squared. dy over dx is negative 1 divided by square root of 1 minus x squared. You need to see more detail. 1 minus x squared, since x is cosine of y by definition that we have here. So the derivative of inverse cosine is negative 1 divided by 1 minus x squared.